Hello, hello. I think I'm live. Maybe I'll wait few seconds to tell the stream like hits the YouTube servers or till the stream starts on YouTube. Okay. Okay. I think it's up. Yes, it's up. Let me tweet. So probably I should set up the Twitter stream also. Live now. Gonna work on aggregator. Yeah, C437. Join in. Okay, now that's working. Let's open our browser. Let me, you can see the browser, right? Okay, now that's done. Is this correct? Yes, it is. So, yesterday we read the aggregator, what was that? Aggregator specification, but we didn't find any example in account abstraction repo. So, I'm just gonna search for that ERC4337 aggregator GitHub and see what every rest of the people are doing with that. Okay, let's put this in quotes. Face account, okay. I aggregator. We have read this yesterday. Validate aggregated signature. Revert if aggregated signature does not match given list of operations. Aggregate multiple signatures into one single value. Okay, should we search for zoomed in, right? 125, okay. BLS signature. BLS signature. Light dark, okay. Cryptographic. Combine multiple signatures into one. No, crypto. Signature aggregation BLS. Okay. What's this? BLS multi-signature aggregator with mul- BLS multi-signature with public key aggregation. Okay, for this we need to understand BLS, um, or what whatever that is. And I know if we go to Solidity GitHub, yeah, this vectorize.eth. In this, there is something for BLS. Auth, no. BLS. Okay, so it's here. Notice BLS wrapper, author, okay. Dev precompile address. For this multi signature verification and multi signature verification. Last post. Can I just start? Okay, I can. I just have to log in, and incognito. It's not doing that. Sign in. Sign in. Sign in with email. Okay, I'll sign in and come back again. Okay, now that's done. I'm just gonna listen to this instead of reading. That's much quicker. You guys may not be able to hear it, but let's see. Okay, now that's done.
Work in
You
Bitcoin.
guys may
A quick
not be able
recap
to.
on allowing us to perform scalar multiplication. The scalar multiplication from one point to another point is easy to compute, but working backwards is hard. The key equation, P equal
Okay, so I'm not sure if I should put this audio on, so I'm just not gonna push it here on the stream. So you guys can just follow how this person, like how the system is reading this, and you can read it. Otherwise, I'll just put link in the chat somewhere if I can find chat. Okay, link. Okay, it's in the YouTube chat. You guys can read it. Multi-signature scheme. Okay, let's not spend time on this. Instead, what we can do is you can Google search signature signature aggregation solidity. Oh, okay, understood. Yeah, they are also doing the same thing. I haven't read this yet. Okay, I understand this part. Differences between ERC for validation range. So there isn't any code. Like the this is not code. This is just function signatures. How things will work under that, under the hood for that. Validate user of BLS. I know BLS will be published. BLS precompile will be published with what Spectra upgrade, Spectra upgrade, BLS precompile. Is there is a BLS precompile? I don't exactly remember. Yes, EIP. This particular thing. Sorry, this particular EIP 2537 that will be shipped with Spectra upgrade this year or this quarter sometime. So should we should be able to test this. Well, like not test this, but with uh, this Ithaka. How do you pronounce it? Pronounce this? I know this is project from who Paradigm or a company who is p- funded by Paradigm. Ithaka crypto. Yes, this one. But that's not important. What is important is we go here. It says example. BLS multisig based on okay. Rust Python. Contract view memory avi.encode hash to curve g2. Don't know what that is. Imagine DAO. Imagine a DAO consisting of 100 members, signers in total, where at least 50 members need to approve any transfer of funds from treasury to ensure that fund cannot be misused without sufficient consensus from key holders. EIB 2537 introduces a set of precompiled contracts enabling elliptical curve operation directly on Ethereum virtual machine. This makes feasible to use PLS signature natively on Ethereum and dramatically reduces the cost and complexity of these operations, unlocking efficient use of BLS based signature schemes like multisig. We demonstrate a simple multi-signature contract BLS multisig which keeps list of signers public key and allows executing arbitrary operations which are signed by subset of signatures both stored both stored public key and signature can be aggregated, thus allowing for much better scalability for large number of signatures versus ECDSA. Let's walk through code. Okay, VLS VLS signing operates on two curves G1 and G2. In our case, we'll store public key on G1 while signatures and messages will be on G2. To sign and verify message consisting of arbitrary bytes, we need to first map the message to point G2. There is a commonly used algorithm for mapping. We are using its implementation in Solidity. Okay. Let's okay, we are here. We in Solidity. Yeah. First code block. Let's see in Python like where is the Solidity file? That's what I want to see. Contracts, source, BLS signature. Okay. Store signer. Notice negated. Okay. Constructor signature threshold. What is threshold number of signature required to execute an operation? We don't want to execute anything. What we need is where was this? Let's go to account abstraction. Implementation. No. ETH infinitism. Account abstraction. Source. No. Contract. Sorry, not source. And I aggregator. It's saying validate signatures. Validate user op. Validate user op signature will be called by bundler. Okay. Aggregates multiple signatures into one value. This method is called off-chain to calculate signatures to pass with handle op. Bundler may use optimized custom code to perform these aggregations. This aggregation. Array of user ops. I don't know who to try. Like, let's go to specification again. ERC4337 EIPs. First one, agree. In the flow, they are saying this was the flow basically. An account signifies it uses signature aggregation by returning address. We understood that. During simulate validation, this aggregator is returned to bundler as part of aggregate info field in validation result. We know that, or I'll at least show you what we have seen this, but this is the thing bundler will run. Bundler will run, and while doing that, it calls this simulate validation. Simulate validation return value is validation result, which is a struct, and in that aggregator info is returned. And if we see that struct, the last value is aggregator info, which is also struct. Yes, it returns aggregator and the stake info, address of the aggregator and the stake info. Stake info will be value, some, yeah, stake and unstake delay in seconds. Okay, all aggregator must be staked. That I understand. Bundler first, the bundler should first verify the aggregator is not throttled or banned according to, okay. To accept user operation, bundler must call validate user op signature. To validate, this method returns an alternative signature that should be used during bundling. Okay, so in terms of this, oh no, sorry, I was reading this part. First, we already knew that these 3 points, uh, 1, 2, and 3, these are for bundlers. This is also for a bundler, but now the implementation part will come in. To accept the user operation, bundler must call validate user of signature to validate user of sorry to accept the user operation. The bundler must call validate user of signature to validate user of signature. This method returns an alternative signature that should be used during bundling. An alternative signature is normally an empty byte array but can also contain some data for this. Bundler must call validate user of second time on the account with user operation using returned alternative signature and make sure it returns the same value. So this part I'm confused. I understood this. Does validate user of even returns anything? Okay, back here we can check I account. Yeah, validate user of has something, but it uh, aggregated. Open in new. I want to open that in new tab. Go at the top and uh, this part. Bundler must call validate user of second time. Okay, so what what we can do is not really sure. It returns a validation data. Why is it saying using using the returned alternative signature in the user operation packed user operation? Let me show Excel it. Okay, let me turn this to dark mode. So we have three boxes. Uh, yes, let's align them. The flow will be we have bundler, then we have entry point, we have aggregator, and we also have account contract. Let me zoom out. So now we can check here. Account An account signifies it uses signature aggregation by returning its address with validate user of. Then we can say here there is a function val validate user of. Let's say it's here, and this function returns validation data, which is address uint 48 48 oh no uint 48 uint 48. This will be 20 bytes, 6 bytes, 6 bytes. So validation data is uint 256 32 bytes. Just key. Now this is address of the ag aggregator, valid until valid from. We can ignore these values. They will be 0 anyways. Okay, so this is valid after and valid until. That makes sense. Now we know this should return this if it's using aggregator. If account is using aggregator, it will return following data. Uh, data return data in following structure. Okay, that's cool. We need we need to keep that in mind. Then next was next simulate validation aggregator info. That doesn't matter. To accept these three are offline functions, so we can ignore them. To accept the user operation, bundler must call validate user of signature to validate user of signature. This method returns bundler must call validate user of second time with alternative. Implementation of an aggregate signature must aggregate all user of signature in single value. Note that the above methods are helper methods for bundler. The bundler may use native libraries. Okay. Implementation of valid signature must verify aggregator signature. signatures validity for all user operations in the array. Okay, I want to see, let's go in the entry point, aggregate. Okay, so what we can do is this. No, I was here, right? In the VS Code, not on the browser. So I want to check op length. So this, it takes length of that array, saves it in op length, total ops 0, ops opas length. Then aggregator, it takes this. Okay, why is it type definition? Fact user operation, aggregator signature, aggregated signature. Okay, one thing I'm confused about here is that if we go, how, why this bundler has to call validate user op with signature, because we are telling it to go and find the signature, get the signature from aggregator. I don't understand how that flow will work. Let's go to VS Code, fact user operation, validate, okay, ops, where, oh no, it's just getting all the user operations from this. I aggregator, it OPAs, and the identity point I aggregator. Type definition, no, did I mess up somewhere? No. Oh, okay, it checks as a this type. This is a contract basically, not a struct. I was trying to find where is that is that struct. Next is it does a validation, validate prepayment. This is similar to the first one, emit before execution. It takes aggregator one, signature aggregator changed aggregator. OPI.aggregator. Okay, so this array has combined user ops. So whenever first first element of this array will be one aggregator, then second, then third. So that's why we have this emit event here. Then it executes at the end it says 0, so we'll know when execution is finished. Correct. No, not type definition. Go to definition. Aggregate, get validation data. Definition, parse validation data. Data aggregator. Okay. We know everything, but I just don't understand the flow here. Where where the basic issue is not check not checking, not understanding the flow between bundler user operation, bundler account contract, and the bundler account contract entry point and the aggregator. So a bundler doesn't really matter, but interaction between entry point account and aggregator is not very clear. Maybe because there is no example of it. Maybe that's the reason why it's not clear. Okay, back to VS Code browser. Can we find ERC4337 signature aggregation GitHub? Okay, this one looks like something. A, se- a set of smart contracts to bring gas for multisig wallets. Bring lower gas contracts to bring lower gas costs for multisig wallet on EVM via aggregated BLS signature. Oh, this is work in process 2 years ago. Pretty sure it's not completed. Oh, cool. Aggregator. Okay, I understand. BLS domain, validate signature. Oh, we have something. That's pretty cool. Aggregate signatures. So it is not following. Sorry about that. I have to. Yeah. Now its size is correct. We have different stand. Yeah, aggregate signature, validate what we have. v- Validate signatures, aggregate signatures, validate signature, aggregate signature, validate user of signature. That's not there. But Okay, that function is called by bundler. So even if we don't implement it right now, it won't affect any functionality. Validate aggregate signatures. It will pass everything. Okay, let's take a look at this more. Some libraries that we don't understand. Aggregation authenticator. Okay, so this is something related to safe. Our only concern is understanding this. For validation, validate external override. Why doesn't it return anything? The function definition? No, it doesn't have to return anything. Copy must verify signatures. So this is correct. If it doesn't revert, then that works. That's how they assume if it's correct or not. Yes, that's how they check. If the view function reverts with an error, um, that's the end of that validation. If not, it's good to go. Okay, cool. So where was I? Yeah, here. Tomorrow we'll check this contract and what it is doing. This stream was just waste of time, like for you at least. Not me. I had to do this at some point and to understand the things. Uh, to understand this, basically. Okay, cool. I guess we can end the stream early, and tomorrow deep dive into this. And I'm pretty sure I won't be able to explain what BLS is, but we can at least check. We can at least like go through this and see if everything is correct. I won't. I won't be able to explain you these details about how BLS works because I also don't know how ECDSA works, but I do know how to sign and how to validate that signature. So just keep that in mind. And I'll also put some YouTube links in the chat tomorrow for understanding BLS from maybe some lectures or something like that. So cool. Okay, then that's the stream. Have a nice day. Bye. See you tomorrow at the same time. Okay, bye.